All right, we're going to do a video for each page here. So the first problem, we were given some information about f. So given f of 0 is 4, let's just plot that right now. Given f of 0 is 4, find f of 5 and f of negative 5, and then draw f of x's graph. And we're given information about f prime. Remember, the area under the derivative graph is the change in position for the f graph. So I'm going to divvy this up into some geometric shapes. And first thing I think I want to tackle is the area of each section. Because I know f of 0, and I want to figure out what's f of 1, 2, 3, 4, 5. What's f of negative 5 and what's f of 5. But I also am going to need to plot all the points in between too to get an accurate graph. All right, so what is this area? This is negative. It's a triangle, so negative 1/2 times the base of 2 times the height of 2. So half of 4 is negative 2. What's this area? It's positive 1/2 times the base of 3 times the height of 1. So it's 3 over 2. All right, and then what about this triangle here? Positive 1/2 times the base of 2 times the height of 6. Half of 12 is 6. This is a trapezoid. 1/2 times the height, which is 3, the distance between the parallel sides, times the sum of the bases. So 3 plus 6. So 9 times 3 is 27, 27 over 2. All right. So what is f of 5? Start with what you're given. So, okay, so if I'm going from 0 to 5, I would start like this. F of 0 plus the integral from 0 to 5 of f prime of x dx is equal to f of 5. All right, so we know f of 0 is 4. What's the area from 0 to 5? So we're just looking at this chunk here. So plus 6 plus 27 over 2. So this is 10 plus 27 over 2. That's 20 over 2 plus 27 over 2. That's 47 over 2. And I'm looking to plot points here. So what is 47 over 2? Let's see. 46 would be 23. So this is 23 and a half. So f of 5, I'm just going to do this. F of 5 is 23 and a half. All right. So I'm going to plot that right now. F of 5, 1, 2, 3, 4. I'm just going to say like up here is 23 and a half. Something like that. I don't want to connect the points yet because I want to get concavity correct and all of that. I'm also going to be plotting a point at 2 and at negative 2. And those should be all of my points that I have to plot. Okay, we were also supposed to find f of negative 5, so start in order. So f of negative 5 would be f of negative 5 plus the integral from negative 5 to 0 of f prime of x dx. That should equal f of 0. Right? Start at negative 5, add the change in position, and land at 0. F of negative 5, we don't know. I like to do the area over here instead of subtracting it first, so I'm going to figure out this area first. So from negative 5 to 0 is negative 2 plus 3 over 2, negative 2 plus 1.5, and that equals f of 0, which is 4. So f of negative 5, this is really just this is minus 1/2, right? So if I add 1/2 over here, I get f of negative 5 is equal to 4.5 or 4.5. So I can plot that. 1, 2, 3, 4.5 at negative 5. Oops, make sure I counted right. 1, 2, 3, 4, 5. Yeah, so that's about here. Okay. And then what about the other points? So like I said, I want to accurately place points at negative 2 and 2 because that's where some of the graph changes over here. Or actually, let's see, I can do more than that. Okay, how about this? From negative 5 to negative 3, from negative 5 to negative 3, the graph goes down 2 units. So from, my point erased, 1, 2, 3, 4. So from negative 4.5, I can go down 2 units. So 5, 6.5. So at -3, I should be at -6.5. I think I'm going to write these here because it's kind of hard to see without a grid. Oops, why was I plotting negatives? Sorry, 4.5. At -5, we're at 4.5. 1, 2, 3, 4.5. I wrote it down correctly. I plotted it wrong. At -3, we're down 2 units. So 4.5, 1, 2, down 2 units. So I should be here at 2.5. So this is -3, 2.5. This is -5, 4.5. Sorry, guys. Okay. And then what's our next point? We have a point at 0. Let's figure out the point at 2. So from 0, we go up 6. So we were at 0, 4. If we go up 6, I'm just going to call this 2, 10. Okay, and then we already have our point at 5. Now, how do I know about concavity and curvature and all of that? So you don't have to worry about the decreasing, increasing part. We already have that based on the points. But concavity, remember when f prime is increasing, that means that f is concave up. And when f prime is decreasing, that means that f is concave down. You can write on your f prime graph. So the graph for f should be concave up between -5 and -2. So concave up, I'm just going to kind of sketch it. Excuse me. Sketch in like this. I didn't plot a point at -2. I guess I could have. And then the graph switches for f, switches to concave down. So something like that. It's kind of hard to sketch that in. Excuse me. All right. And there is like at -3, there's this little, here, let me do it like this. At -3, there's this little horizontal tangent, right? So I should have drawn it more like this. There we go. That looks better. Okay. And then f goes back to concave up because f prime is increasing. So concave up on this section, and then back to concave down. If f prime is decreasing, then f is concave down. So something like this. All right, what about this one? Given f of -1 equals -2, find f of 10 and f of -9. So nothing to graph here. So I'm going to start, okay, if I'm starting at -1, f of -1 plus the integral from -1 to 10 of f prime of x dx, that will equal f of 10. F of -1 is -2. What about this change in area here? So from -1 to positive 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is this area? It's -1/2 times the base. This goes from -1 to 8, so that's 9 units across the base. The height is 2. Half of 2 is 1, so this is -9. This little triangle here is 1/2 times the base of 2 times the height of 1. So that's 1. So -2 plus -9 plus 1 is equal to f of 10. So this is -8. -2 minus 8 is -10. So f of 10 is equal to -10. What about f of 9? That's to the left of f of 1. So f of -9 plus the integral from -9 to -1 of f prime of x dx is equal to f of -1. Right? I always like to do it in this order, and then I'm going to go through and solve stuff. So I don't know f of -9. What's the area from -9 to -1? So here's -9, right? Because this is -8 to -1. So this area is 1/2 times the base of 2 times the height of 4. It's 4. This area is -1/2 times the base of 2 times the height of 4. -4. This is also a triangle, right? This is 1/2 times 1, 2, 3, base of 4, height of 3. Half of 4 is 2 times 3 is 6. Okay, I was just drawing that height in there. And we're stopping there. So this is -4, 4 minus 4 plus 6 is equal to f of -1, which was -2. So we don't know f of -9. This is just 6, right? So I'm going to subtract 6 to this side and get -8. This is the fundamental theorem of calculus that we're using. The acceleration of a particle was given by this, where a of t is in feet per second squared, t is in seconds. The particle is at rest at 0. So what does at rest mean? At rest means that the velocity at 0 is equal to 0 feet per second. Find the total distance traveled from 0 to 3 pi. We're going to use a calculator for this one. So actually I need to get mine open. All right, so remember that v of t will be equal to the indefinite integral of a of t dt, right? And we're looking for the total distance from 0 to 3 pi. In order to get total distance traveled, I need a velocity formula first. So first off, I have to figure out what is the velocity equation. So I need to integrate the sine of t over pi minus pi over 8. So this is a u sub. So there we go. U is going to be t over pi. Du dt is going to equal 1 over pi. So multiply dt over here. Instead of 1 over pi, it would be pi times du equals dt. So now let's do some substitution here. So we have the integral of sine u du times pi minus pi over 8 integral of dt. I'm going to split it up like that just because I have u sub and not u sub. What's the integral of sine? Negative cosine. And instead of u, I'm going to put in t over pi. And then minus pi over 8, the integral of dt is t plus c. Remember that at 0, we have a velocity of 0. So 0 is equal to pi times the negative cosine of 0 minus 0 plus c. 0 in there. Cosine of 0 is 1. So this is negative pi plus c equals 0. So c equals pi. All right. So I want the total distance now. Total distance is the integral from 0 to 3 pi of the absolute value of v of t, which is what? Pi. How about this? Negative pi times cosine of t over pi minus pi over 8t plus pi. Pop this into my calculator here. So math, 9, 0 to 3 pi. Absolute value is math, number, absolute value. I'm in radian mode. Negative pi times cosine of x over pi minus pi over 8 times x plus pi. Make sure you put in the dx. And I'm getting approximately 11.628. What would the measurement be in that? So acceleration was feet per second squared. We're down to position now. So that's a total of that many feet. All right, next video will be for page 2.